Hi, welcome to Lesson 20, Session 1. Today we're going to be working with multiplying fractions to find the area of a figure. We might be using tiling with unit squares to find the appropriate unit fraction side lengths. We might be multiplying the side lengths to see what the area of the total figure is. But regardless of the method that we use, we are always going to get to the same result. And that's kind of what we're going to learn and see today. So with that, we are going to be working in our Ready Classroom Math Workbook on pages 403 through 406. So go ahead and turn to page 403 in your Ready Classroom Math Workbook. Okay, so I am in my Ready Classroom Math Workbook right now, and I am on Lesson 20, Explore Multiplying Fractions to Find Area. So previously, you learned about multiplying fractions. Now you will use area models to multiply fractions and find areas of rectangles. Use what you know to try and solve the problem below. So first of all, let's ask ourselves the same three questions we always ask ourselves when we start a word problem. What is the problem talking about? What is it that we're trying to solve? And what is the important information? Those three questions, if you ask yourself those every time you do a word problem, it's going to help you so much. So let's go ahead and start. First of all, here's the problem. It says, Mr. Thompson designs a 1 mile square park. He makes a square with 5/10 of a mile sides on his design for a dog play space. How many square miles of the park does he use for the dog play space? So first of all, we are talking about a park that has a dog play space. That's what this question is talking about. What is it that we're trying to solve? How many square miles of the park does he use for the dog play space? And then finally, what is the important information? We know that the park is 1 mile, a 1 mile square park. We know that he makes a square with 5/10 mile sides. Now, I'm going to go ahead and show you if I were going to draw this picture, what it would look like. I'm going to go ahead and zoom in just a bit so that you can see a little bit better. Okay, so to begin, this unit square here represents the whole park. And it is 1 square mile. Now, the first thing that we learn is that Mr. Thompson draws, he makes a square. So we know that if it's a square, it's going to have all of the sides of a square are what? I hope you said equal. All of the sides of a square are equal. So if one side is 5/10 of a mile, that means the other side is also 5/10 of a mile. Now, the wonderful thing about this hundredths chart that I have down here below is that it is already broken up into tenths because each column is 1/10 and each row is 1/10. Now, if we come and we look up above, we know that each side of the square that he drew is 5/10 of a square mile. So if we count over and we go over 1, 2, 3, 4, 5, and we count down 1, 2, 3, 4, 5, and then we fill in that square. There we go. What that square shows us is one side is 5/10, and the other side is 5/10. Because each of these, each column represents a tenth, and we know that one side is 5/10 of a mile, and the other side is 5/10 of a mile. And then we drew our square. So now we know that we have this space, or the dog, I'm going to call it the dog play space because that's what it is. The dog play space is 5/10 of a mile by 5/10 of a mile. And if we went through and if we counted how many squares fill in all of this space, we would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So we can see that we have 25 squares. Now, one of these squares is worth how much? What is the value of one square when we have a hundredths grid? 1/100th. Yes. Remember that each of these tiny squares is 1/100th. That's why this is called a hundredths grid. So if we have 25 inside of the space, how many do we have in the entire hundredths grid? That's right, 100. So the answer is the dog play space covers 25 hundredths of a square mile. All right, if that doesn't make sense to you, don't worry, we're going to get tons of practice. But remember, you can always remember that you also know the other method when you're multiplying fractions. When we're multiplying fractions, remember, we know how to solve this. Multiply your numerator times your numerator. Bam. Denominator times your denominator. Bam. So you get the same result, but here is a picture that represents the equation that we already know how to solve. So now, since you know how to solve the equation, you're going to spend the next few days learning how to draw the pictures that go along with the equation that you know how to solve. Let's go ahead and go to the next page. All right, it says, explain how you found the area of the park used for the dog space. Well, in our case, we drew an area model to show that 5/10 times 5/10. The shaded section that overlapped was 25 hundredths. So if I go back, I realize now that if I went back, there was a second way that I taught you guys how to do this. So I'm going to go back and show you because sometimes I forget what I've taught you and what I haven't. So if we wanted to shade in 5/10 of this figure, we've already broken it up into tenths, and then we're going to shade in 5/10 of this figure with pink. The pink represents the columns. Then I'm going to use the yellow to shade in the rows. And I'm also going to shade in 5/10 of the rows. As you can see, the overlap, the section that we already counted, the overlap is the product of what is 5/10 times 5/10. The numerator is the orange section. In this case, it's orange because the pink and the yellow overlapped. So the orange section, or the overlap, and then the denominator is the total number of equal parts in the whole. So we know that there are 100 of these tiny little boxes, and these are all equal parts. So there are 100 equal parts in this whole. And the overlap, in our case it's orange, the overlap is the numerator, which is 25. All right, now we can go back. Sometimes I have to go back and cover a little bit that I didn't cover before. Okay, now looking ahead, suppose you want to find the area of a rectangular section of the park that is 3/10 of a mile by 3/10 of a mile. You can find the area in different ways. You can tile the section with unit squares, which we see here. The 1 mile square park is divided up into 10 columns and 10 rows, so that one of these tiles is 1/10 of a mile times 1/10 of a mile. Because remember, each column is 1/10, each row is 1/10 of 100. So if one of these squares, if we're just looking at just one of these squares, is 1/10 of a mile by 1/10 of a mile, what is the area of that tile? Remember, area equals length times width. So if we did 1/10 of a mile times 1/10 of a mile, what would we get? That's right, 1/100th of a mile, or a square mile, excuse me, 1/100th of a square mile. So how many tiles are in the 3/10 mile by 3/10 mile section? So now we're looking at the section that is 3/10 of a mile by 3/10 of a mile. How many are in here? We have 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 in the 3/10 of a mile by 3/10 of a mile section. So now, if we know that one of these tiles is 1/100th and we have 9 of them, what is the area of the 3/10 of a mile by 3/10 of a mile section? To find that, we would say, what is 1/100th times 9, which equals 9/100ths. We also could have solved that a different way. You can find the area by multiplying the side lengths of the section 3/10 times 3/10. If we multiply 3/10 times 3/10, we know that that is the same as saying 3 times 3 equals 9, 10 times 10 equals 100. So the area of the section is 9/100ths of a square mile. Now let's go back and reflect on what we've talked about today. Looking at the area model for the equation 3/10 times 3/10, so looking at this area model, explain how the numerators, which are the 3's, and the denominators, which are the 10's, in the equation are related to the squares in the model. So the 3's here, and the 3's here, and the 10's here, and the 10's here. In both the equation and in the area model, the numerators show the number of shaded rows and columns. So in other words, we know that if we look at the numerator, this numerator here tells us we're going to color in 3 columns because the numerator is 3. The numerator in this factor is going to tell us we're going to shade in 3 rows because the numerator is 3. The denominators show the total number of rows and columns. So if our denominator is 10, that tells you that if we are going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 columns. And if the denominator in this factor is 10, we're also going to have 10 rows. So the numerator tells us how many we shade. The denominator tells us the total number of columns. In this case, it's the total number of columns. And this is the shaded section. This number 3 is also the shaded rows. This would be, instead of saying shaded section, I'm going to say shaded columns. And then this 10 is going to be the total number of rows. We're going to practice this plenty, but I just wanted to give you that really good, hopefully good understanding of what each of the numerator and the denominator mean when we're drawing an area model. So now we're going to move over to our graphic organizer, and we're going to talk about an area model. So what is an area model? An area model is a rectangular model used to show multiplication. What do we know about an area model? We know the side lengths of the rectangle are the factors of a multiplication problem. So these are our factors that we're multiplying to solve the problem. And the product, or the answer to the multiplication problem, is the area of the rectangle. So if we want to know the area of this rectangle, we multiply the length times the width, or the two factors. So that's what we know about an area model. Now, some examples of an area model. In this case, if this rectangle has a length of 6 and a width of 4, we know to find the area, we're going to multiply 6 times 4, and that will give us an answer of 24 square inches, because we're multiplying. And remember, when we're finding area, it's square inches. When we're finding volume, it's cubic inches. Again, when we're finding area, it's square inches. If we're finding volume, it's cubic inches. The area model in this picture shows us what is 3/4 of 1/2, or what is 3/4 times 1/2. Now, we all have learned how to do this equation. We multiply 3 times 1, our two numerators, to get a new numerator of 3, and we multiply our two denominators to get a new denominator of 8. But what does that mean when we're looking at an area model? To draw the area model, what we do is to draw the factor of 1/2. We take our rectangle and we cut the rectangle in half, because there are two parts. Remember, the denominator tells us how many parts we have, and then the numerator tells us how many columns we're going to shade in. So this one tells us we're shading in one section. Then we go to the other factor. The denominator, the 4, tells us how many parts are in the rectangle, and then the numerator tells us how many we're going to shade in. In this case, our pink section is the half, showing us half of the area model, or half of these section, and then the yellow is showing us the 3/4. The way that we find our product looking at an area model is the overlap, in this case, which is 1, 2, 3. The overlap is our numerator. The denominator is the total number of equal parts in the whole rectangle. We have to count all of the numbers in the whole. We can't just count the shaded section like when we were multiplying decimals with an area model. In this case, in order to get the answer, we have to find out how many are shaded for our numerator, and then how many are in the whole. So 1, 2, 3, 4, 5, 6, 7, 8 to get our denominator. And then here's another example. If we had 2/3 times 2/3, we drew this rectangle. We cut it in 2/3 because the denominator's 3, and then we shaded in 2 blue columns because to show 2/3 of the rectangle. Then in yellow, we shaded in another 2/3. We broke it up into 3 rows because the denominator was 3. And then we shaded in 2 rows because the numerator was 2. To find our answer, the shaded section, which in this case is 4, is our numerator, and the number of equal parts in the whole, in this case is 9, is the denominator. With that, you're going to go ahead and finish number 2, and then do numbers 3 and 4 on the next page. As always, if you have any questions, you can email your teacher. See you next time.